Welcome to this video on how to build the Kadee Servo controlled uncoupler. I designed this to be as simple as possible to construct. You can 3D print this. I would use PLA Plus or PETG to print the thing. I used a 0.2 layer, 0.4mm nozzle, and I printed it on a basic Ender 3 and an Ender 3 KE. So this will go together fairly easy. Now what I'm going to do in this video is show you how to actually put the parts together. But first let's just see the unit in action. So that's the unit actually working. I'm sorry I couldn't show you it uncoupling and coupling between two wagons, but I just couldn't hold the camera and operate everything in one go. But it works fine, obviously, when you need to uncouple vehicles. Right, let's see how this thing goes together. So these are the parts. Obviously, you've got the top servo cover. This one has the servo in, and I'm not going to take it out because these press in really tight and I really don't want to pull the thing out again. You've got the main sort of base. This is a jig, a cutting jig. So you put this over the track to work out the area that you need to cut out to obviously put the item in place, because one of the things with these units, they need to be centered on the track really well. This is the main flap. And then you've got the magnet holder. Obviously this bit sticks on top of this bit, and then you put the magnets in, as I'll show you in a bit. And then there are a range of spacers that are included in the STLs. This is because you want the unit to be able to, when this is under your track, you want your track going across the top of this, but you want it as close to the sleepers as possible, but you don't want so much pressure that you put a bow in the track. So these spacers are just there to allow you to sort of offset the lid underneath the layout as you need to. Now finally, there is this piece of brass tube. I've used it's 3mm diameter, 50mm long. I have used brass tube because I just happen to have some brass tube. Just find something that's 3mm diameter and strong enough. This works as the, if you like, the pivot through here to build your hinge. Then there are the two screws that come within the servo kit. Now, I have put the holes in on either side to put these screws in. I'll be honest, in all my testing, I've never used the screws because I'll be honest with you, the servos are so tight that there's been no need. The servos themselves that I'm using, let's just bring this one over. I am using these little servos. They are an MG90. I use the MG90. There is a blue servo, I think it's called an SG90. I prefer the MG90 because it's a few pennies more, but it has metal gears, so it should last longer. Finally, of course, we have the magnets. Now these are 60mm by 10mm by 3mm, and they are N35 neodymium magnets. I don't know how you pronounce that word, but anyway, those are the magnets. And if you go to the resource page on the Digital Town site, the 3D printing resource page, you will see a link, if you like, the description of the magnets. So those are the magnets you're going to need. That's all the bits. Let's show you how it all goes together. So we'll start off with the top plate. Now, once you've obviously printed the thing out, next thing you need to do is put the servo into it. Now, the servo goes in quite easily. You just push the thing down. However, before you put the servo in, what you need to do is connect this to your Arduino or your ESP32, and you need to set the servo to a position of 90. Once you've set the servo to a position of 90, then put the connector on the top, and that is all you need to do. But obviously you need to set it to 90 first, because if you put it in a different position, you will not have the range of movement that you need to activate the unit. Once you've built the top plate, got your servo in, the next thing is to build this unit. As you can see, you've got the magnets that go flush against the top. You've got this flat plate. This is a section that the servo actually pushes against. And then obviously you've got the main board. Now, the first thing is, when it comes to the box itself, take your bit of 3mm and just force it into the holes. You want a tight fit. You don't want a loose fit on this section. However, once you've got that working, when you come to the actual flap, you need to push this thing in. Obviously, if you've got any excess print that's come in, you need to work it out. I actually had to touch this one just lightly with a file. Other ones, I've just put it in, sort of rotated it a couple of times, and it moves. But you want it so that this piece moves freely. So those are the two, if you like, parts of the hinge that you need to get ready. So now we come to the flap assembly. I've got a different coloured one here. It's literally a case of place one on top of the other and just push down tight, and they do go together really tight. I've stuck this one in earlier and I just cannot get the thing to come off. If they are slightly loose, this is where a little dab of super glue, probably just around this joint just to soak in, or underneath here, is all that you're going to need. But obviously you need these two bits to hold together well. Now we come to installing the magnets, and this is where you need to take a little bit of care. So this is one of the flap units. This is another one that I've built earlier. I've taken some of this 3M double-sided foam tape. It's about, what, 2mm thick. And I've cut a couple of pieces and put them into the recess. This one, obviously, I've already put it in, and I've put in the first magnet. However, when you come to putting in the second magnet, be careful with these magnets because they really are strong, and they can be a little bit vicious on your fingers. Carefully bring the magnets together and find out, there you see, those two have now gone together. Now what you need to do to make this work really well, I don't know whether it's to do with the magnetic fields or just in my testing, but what I found is if the two magnets stick together like this, then this side here needs to be the other way up. So if you like, this face of the magnet here should be the face that would naturally stick to this magnet over here. So once you know which way up the magnet needs to go, obviously just stick it into the other recess and you're just about ready. Then it's just a case of putting the two together, pushing the bar through, and you will finish up with a unit like this that obviously moves up and down. Now once that's done, if you want to test the unit, I just get a bit of blue tack and stick the flap in the up position. Then you can put your piece of track over the unit. Let's just get that straight. And as we can see, if I get the track roughly centered, as the wagon comes across, you can see the coupling being pulled open and to one side, as it should be. Finally, to finish the unit off, all you need to do is take the top plate, push it in place, and that's it. This will then screw into your baseboard and it should push the base of the unit up against the base of your track. And as you can see, when the servo is twisted open, you can see that the flap sits at an angle, and then as the servo moves, it pushes it down into a position where it will uncouple the wagons. Now I'm just going to talk about track positioning, because if I bring this wagon down, obviously this is working nicely. If I move the track too far over, that's fine, but obviously going the other way, the coupling won't uncouple. The same if you move it too far over this way, you can actually see that it's trying to pull in this direction. Now this is why I designed this little jig, and this jig literally sits on your track. There's a couple of little slots in here for the track, and the idea of this is it allows you to mark out the cutting space in your baseboard to fit the unit as square to the track as possible. I had to use this system because my track was already in place, and what I finished up doing was drawing the line around this. Then I drilled some little 2mm holes in the corners, redrew the box underneath the baseboard, and then I used a router set to the width of the plywood of my baseboard to route out the space under the track. Obviously, if you're putting this in before you've laid the track, it's going to be much easier, but it is important that you get the unit square. Now, I have tested one of these on one bit of track on my layout where it is actually a very slight curve, and I have managed to get it to work, but you have to make the unit slightly off center on the magnets. So do some experiments on that above before, if you like, you put the track down. So that covers the, if you like, the physical construction of the uncoupler. I will do another video on how to control the servos with a number of options, either as a DCC accessory decoder, or using buttons, or using the NowRail Wi-Fi system. So I'll do some videos on that once I've completed one more video that's got to be done first. So I'll get that done very soon. Thanks for watching, and any questions, please just stick the questions under the video or email me off the Digital Town site. Thanks for watching, and I'll see you in the next video. Bye for now.